This is Grant Jacob from the Blue Running Hedgehogs group, and we will be discussing how to design a hovercraft. Design challenge, problems and constraints. Objective, design and build a hovercraft that will navigate a course in the shortest time possible. Requirements, constraints, and resources. The hovercraft may be powered by battery or AC via an extension cord. Gasoline-powered craft will not be allowed. Design may not incorporate any parts of commercially available hovercraft or helicopter kits. Hovercraft should allow for required movement within the racetrack without any part of the craft going off the track. Any decisions regarding disqualification may be made by judges will be final. The hovercraft may not be pushed or pulled by team members. The hovercraft must be tested in an official FEDD pre-event, and it must be completed within a $40 budget. The course. The course will be laid out on a floor that will be a non-carpeted surface inside of the McKimmon Center ballroom. The floor surface may not be perfectly flat. The course will be less than 40 linear feet in length and 1.5 feet in width. The course will be straight and contain no turns. As a team, the hardest requirements and constraints for us were to be within the $40 budget and to find a battery source that was held on the craft and not by an extension cord.
What on earth is a hovercraft? A hovercraft, also known as an air cushion vehicle or ACV, is a craft capable of traveling over land, water, mud, or ice and other surfaces. Hovercrafts use blowers to produce a large volume of air below the hull and is slightly above atmospheric pressure. The pressure difference between the higher pressure air below the hull and the lower pressure ambient air above it produces lift, which causes the hull to float above the running surface. For stability reasons, the air is typically blown through slots or holes around the outside of a disc or oval-shaped platform, giving most hovercrafts a characteristic rounded rectangle shape. Typically, this cushion is contained within a flexible skirt, which allows the vehicle to travel over small obstructions without damage.
The history of the hovercraft is longer than most people would expect. It dates back to the early 1700s, which is before science fiction novels and the whole science fiction genre was really popularly thought about. The first record of the idea of a hovercraft was in 1716 by Emanuel Swedenborg, and it was a hand-powered model. And since had to be hand-cranked, it required lots of manual power, so it never really progressed much past there. The next big attempt at a major design was in 1877 by Sir John Thornycroft, who was looking for a way to reduce drag and friction on ships. His idea was to build a box of air under them to help them glide across the water, and yet again have people hand pump air into this chamber. And as with the previous one, because it was powered manually, it never really got developed very far. Then in 1955, Sir Christopher Cockerell found through a series of experiments that the best way to get vehicles to hover was to have air distributed in a ring-like fashion when blowing downward. And this is when hovercrafts really began to take off, because there was motors that were light and powerful, so they were able to run hovercrafts efficiently and make them useful, which is how you got the SRN-1, which is the first commercial hovercraft, and that was in 1959, and that's when a skirt was first added to Cockerell's design, and it was used to cross the English Channel.
For materials, we used PVC board, Radio Shack motors, plastic sheet, duct tape, dowel rods, plastic cards, super strength glue, staples, and plastic fans.
Our first attempt at a fan consisted of filing down the PVC, but we were unable to make it thin enough. The benefit to the PVC, however, was that this material was easily shapeable. The final two fans were made from a plastic card and a pre-made fan. One was mounted to the back for steering, and the other was mounted pointing downward in the middle to fill the skirt with air. Our first attempt at a base consisted of using the PVC board. This board was sliced down to a thinner size and then sanded. 3 pieces were glued together using super strength glue, and a hole was cut in the middle for the fan.
For our final design of our first attempt, we attached a small wall made out of PVC to the top of the center hole in order to mount the fan in the center. This didn't work for us because the wall wasn't high enough and the fan still hit the ground. The setup of the fan on the back worked, and we carried that over into our next design. The skirt on this design has a hole in the bottom, which was also used in our next design. Overall, this design could have worked, but it was too large for the fans we had to use, and they were not powerful enough to provide lift. For attempt 2, we used all of the same materials except for the base. We switched to a styrofoam board from PVC, and we mounted all of the original materials onto the styrofoam. The pros of this design were lighter weight so that our fans were capable of providing lift off the ground. Cons of this design were that the back fans were not strong enough to propel the craft forward. This led to lack of control, and the hovercraft shimmied along the ground.
Let's go look this way now. Okay, so what we need to do is switch those two and...
So our last attempts were all done in rapid succession of each other, so it's hard to differentiate one from another. So the final craft, the changes from our second attempt, there was a skirt that was added. We kept the hole in the bottom of the skirt. We played with different orientations as to whether it was going to fly sideways, forwards, backwards. We added an upper deck to hold the components, as well as we moved around the battery placement and added a switch to help with the balance. The pros of this were that it lifted off the ground better and it hovered and moved smoothly due to the skirt, but we were unable to control it, it could not be steered, and it would not go straight. Sometimes it would go straight for a little while, but then it would just start curving because we could not get it to balance correctly.
Results and performance of the hovercraft at FEDD. At FEDD, our hovercraft did its job of being able to hover. However, instead of making it down the table in a straight line, it began to spin slowly. The group, we considered this a successful project, considering the time that we had to make the hovercraft and the funds that we were able to use. What we would do differently. We would have started the project earlier so that we could continue making alterations to the design of the craft. We had wrongly assumed that since we followed a design fairly closely, that it would work the first time and we would be done. However, it took us multiple new designs to finally find one that actually worked. Had we started earlier, it would have made it much less stressful to change designs because we would have had more time to find more suitable materials or research more designs. Also, we should have put greater focus on the weight of the materials. We spent too much time using the integrator account. It would have taken less attempts to get the hovercraft off of the ground.
Some advice for next year's freshmen. What to do? First of all, make sure to schedule your meetings and stick to your schedule. If you get behind, it can be very hard to catch up. Stay on top of your work and get things done ahead of time. 2. Make sure to try out different designs and materials. We found that styrofoam worked best because it is lightest and easily shapeable. 3. Find a fan that is large enough and strong enough and keep the motors small and cheap. Small but high-powered fans are ideal for the middle fan. Lastly, use a skirt. Plastic sheeting works best. Some things that you should definitely not do throughout your project include procrastinating. Our group struggled a lot with time management and planning meetings. Secondly, do not wait until the last minute to start your project. The less time you leave yourself with, the less time you have to test and build better models. Lastly, do not forget to have some sort of presentation at FEDD. This should include the history of your hovercraft, the patent you researched, as well as how you use the engineering design process throughout your project.
In total, it cost us $28.67 to build our hovercraft.